2,000 years ago, humanity built a machine that should have changed everything. It spun using steam. It proved a revolutionary idea was possible. And then nothing happened. The world wasn't ready. The knowledge, the materials, the economy, none of them could support the idea. So the invention faded into history, remembered only as a curiosity. Today we may be standing at a similar moment. Once again, we've built a machine that seems to defy common sense, a machine that promises enormous power, but only if the world around it is ready. This is not just a story about technology, it's a story about timing, and about a question humanity keeps asking. Are quantum computers the next industrial revolution, or another brilliant idea that arrived too early? This is the story of revolution that arrived too early. All right, listen closely. Welcome to Query Flux. Science is full of stories that quietly sit in history until one day they explode into the future. And today's story is exactly like that. Let's rewind the clock way back to ancient Alexandria in Egypt, a city of scholars, engineers, and wild ideas. At the time, it was under Roman rule, but intellectually, it was light years ahead. Around the 1st century AD, a man named Heron built a strange little device. It was called the aeolipile. Now today, people sometimes describe it as the world's first steam engine. And when you hear steam engine, your brain probably jumps straight to the Industrial Revolution. Factories, trains, machines reshaping human civilization. So naturally you'd expect Heron's invention to have changed everything. But here's the shocking part. It didn't. In fact, even Heron himself seems to have treated it as nothing more than a clever toy. Why? Because technology doesn't exist in isolation. Back then the math wasn't ready. The engineering wasn't ready. The materials, the manufacturing, the economic systems, none of them were ready. The idea appeared centuries before the world could use it. So the aeolipile spun, amazed a few people, and then quietly vanished into the history. Fast forward almost 2,000 years. Now humanity is staring at another strange machine, one that sounds like science fiction, the quantum computer. And once again, we're asking the same question. If this thing actually works, will it change everything? Or will it become another aeolipile, brilliant, fascinating, and ultimately forgotten? Let's find out. First things first, what is a quantum computer anyway? Now here's the interesting part. A normal computer is a machine that stores and processes information. At its core, it uses bits. Each bit is simple, 0 or 1, on or off, yes or no. By stacking billions of these tiny switches together, classical computers do everything we use today. Quantum computers play by very different rules. Instead of bits, they use qubits. There are many ways to build a qubit, but one common example uses a property of electrons called spin. Spin can point up or down. Sounds familiar, right? Almost like 0 and 1. But here's where reality starts getting strange. Quantum physics introduces two concepts that don't match everyday intuition at all. The first is superposition. In the normal world, we assume an object has a definite state, even if we haven't checked yet. But in quantum mechanics, before measurement, an electron spin isn't locked into up or down. It exists in a blend of probabilities, partly up, partly down. At the same time, that's superposition. Because of it, a qubit can represent 0 and 1 simultaneously until we measure it. The second concept is entanglement. When two qubits become entangled, their states are linked. Measure 1 and the other responds instantly in a correlated way, no matter how far apart they are. When you combine superposition and entanglement, something incredible happens. As you add qubits, the number of possible states doesn't grow linearly, it explodes. That's why quantum computers can be vastly faster than classical ones. But, and this is critical, they're not faster at everything, watching videos, browsing the web, running everyday apps. For those tasks, classical computers are still the champions. Quantum computers only dominate very specific kinds of problems like cryptography, optimization, and simulating the quantum behavior of matter. So even in a future with powerful quantum machines, your laptop isn't going anywhere. So where are we right now? Researchers around the world have been racing to build quantum computers for years. And yes, there have been impressive demonstrations. In very specific experiments, quantum devices have outperformed today's best supercomputers. But don't get carried away. Those successes are narrow and highly controlled. To solve problems that genuinely matter to society, we would need many more qubits, and they must be stable. And stability is the real nightmare. Qubits are fragile. Tiny disturbances, heat, radiation, noise can destroy the information they hold. Many systems must operate near absolute zero, making them complex and incredibly expensive. At some point, it's fair to ask, is all this worth it? Wouldn't it be easier to just keep improving classical supercomputers and smarter algorithms? Maybe, but let's imagine the breakthrough happens. Suppose we build a quantum computer that is far more powerful than today's supercomputers, stable enough for long, useful calculations, and economically viable to operate if that machine exists. What changes first? The most famous answer is encryption. Modern society runs on encrypted information, banking, passwords, secure communication, digital contracts. Many encryption systems rely on one key idea. Factoring very large numbers is brutally slow for classical computers. Small numbers are easy. 55 breaks into 5 times 11. But numbers with hundreds or thousands of digits, classical machines simply can't factor them fast enough to be useful. Quantum computers change the rules. There's a famous method called Shor's algorithm, which, at least in theory, can factor large numbers dramatically faster. That's why people warn that powerful quantum computers could crack today's encryption. So does that mean the internet collapses overnight? Relax, not quite. Quantum computers threaten certain encryption methods, but scientists haven't been sitting still. New systems, known as post-quantum cryptography, are being developed to resist quantum attacks. The likely future is an instant disaster. It's a long, complicated transition, upgrading systems, replacing vulnerable algorithms, and rebuilding infrastructure. Painful, yes. Impossible, no. Now here's where quantum computing may truly shine. Chemistry. The universe at the chemical level is quantum mechanical. Electrons don't follow neat classical paths. Their positions, energies, and interactions are inherently probabilistic. Classical computers struggle with this. They rely on approximations, shortcuts, and repeated simulations, especially when dealing with complex reactions or material interfaces. Quantum computers, being quantum systems themselves, may simulate these behaviors more naturally. If that works as hoped, the consequences could be enormous. Faster drug discovery, better catalysts, more efficient batteries. New materials we haven't even imagined yet. Other fields might benefit too. weather prediction, logistics optimization, financial risk analysis. But let's stay grounded. Quantum computers are not universal miracle machines. Many experts believe they'll transform specific industries while leaving everyday life mostly unchanged, least at first. And there's always the risk of hype collapsing if progress slows. So once again, the future splits in two directions: revolution or disappointment. But here's the real takeaway. Should humanity stop developing quantum computers? Absolutely not. History teaches us this lesson again and again. Technologies often look limited until suddenly they're not. The early internet was once just a tool for researchers. No one truly predicted it would become the foundation of daily life. Quantum computing could follow the same path. The aeolipile disappeared into history. But in another era, it might have ignited an industrial revolution centuries early. So what will quantum computers become? And if timing is everything, then the real question, and that's where the real question begins, isn't what quantum computers can do, it's when the world will be ready for them. That answer belongs to the future, and until then, we keep exploring right here on Query Flux.